Hi, my name is Harvey. In this course, I will be going over some important features of DRATEC Multi-1 routers, such as the 2865 and 2927 series. I'll try to explain how load balancing works with the available WANs, and then we'll have some hands-on session where you'll have a go at setting up and testing some of the features explained. Here is our agenda for this part. First, we will be looking at DRATEC solutions for network reliability, which includes WAN aggregation, load balancing, and WAN failover for multiple WAN routers. We will discuss WAN connection detection, which comes into play when the main WAN fails. But before we begin our training session, I would like to show you first a short video about the speed aggregation when the session-based load balance feature is enabled. This is one of the solutions that DRATEC has developed to address the issue of slow internet connection if there's only one WAN used.
Welcome to DRATEC Australia and New Zealand. My name is Emmanuel Plago, and in this video I will demonstrate the WAN aggregation feature that is available in DRATEC routers. WAN aggregation allows multiple WAN connections, which can be ADSL, VDSL, Ethernet WAN, or 3G and 4G, to be aggregated. This will essentially increase your internet speeds by utilizing the session-based load balance feature in the router. WAN aggregation is supported in dual WAN and multi-WAN routers. Now if you have a look at this table, you can see the different routers which support WAN aggregation. WAN aggregation is useful for businesses that need higher internet speeds to provide users with sufficient WAN speed. For example, if you manage a hotel or own a cafe and provide free or paid Wi-Fi hotspots, and your internet capacity is only limited to the ADSL speed at your location. Now, before showing you the configuration steps in the router, I will demonstrate the WAN aggregation feature using two connections from two different service providers. WAN 1 is using an ADSL connection, while WAN 2 is connected to 4G. First we'll run WAN 1 with the ADSL connection by itself. Our download speed is 23.38 megabits per second. Now, we will run the same test but with just WAN 2 connected. The download speed is 6.28 megabits per second, while the upload speed is 7.32 megabits per second. Now we're going to do the final test where we test the combined speed of WAN 1 and WAN 2 together. As you can see, the total download speed is 30.23 megabits per second, and there is an upload speed of 8.89 megabits per second. This result is the combined total of the WAN 1 speed and the WAN 2 speed. Now let's move on to configuration. To configure DRATEC OS routers for WAN aggregation, first log into your router. If you don't know how to log into your router, click here to view one of our previous videos on how to do so. Now ensure that both your WAN connections are properly set up. Click on the WAN function on the user interface, then click on General Setup. Now there should be a drop down tab that says IP based. Click on this tab and change it to session based. After this, select OK and give it a moment to save the configuration. Now let's move on to the configuration of DRATEC routers such as the VIGA 2960, the VIGA 300B, and the VIGA 3900. Once you have logged into your Linux-based router, go to the Routing tab and select the default routing configuration tab. Click on the drop-down tab on Load Balance mode and select Session Based. Now click Apply and give it a moment to save the configuration. Now after all of this, you can see how easy it is to configure your DRATEC router to enable WAN aggregation. Thank you for watching.
Okay.
What's the difference between the session-based and IP-based?
Okay, we'll cover that soon, right?
Sure.
You see, get this one. All right. So this video, we will do that manually later, right? During one of our hands-on experiment, right? So load balancing. When like the screen shows, there are two WANs. One is 110 megabits per second. Let me see if I can get this one. Okay. My laser pointer. Okay, you get two WANs, right? 1, 1, 1, 2. And so you can use multiple internet connection. You can use the same ISP or different ISP. And you can also allocate the total capacity of one WAN. You can say, okay, I put a load balance policy. I say all traffic from subnet 1 goes to this one, and all traffic for subnet 2 goes to this one, things like that, so that you can load balance it. Or it will do it by automatically, depending what you choose, right? And one of the advantage is redundancy. If one drops, the second one takes over automatically, right? So the benefits of one load balance is you have a reduced reliance on a single service provider. And of course, you increase bandwidth capacity. You have two WANs, much better. You can, using session-based, it will make an aggregation of both. So instead of having 10 on each side, you can have aggregation of 20 megabits per second, right? And yeah, increase internet speed using session-based. The experiment showed it. You just added the two WANs. And ability to use VPN load balance. I will explain that later. And there's no switching delay. If you put it as session-based, the second one will take over. Instead of doing failover, you just do load balancing. The second one will just take over without any loss, right?
Yep.
So the VPN tunnels. So this is a case where there's one VPN tunnel. So if the VPN tunnel drops, everything drops. But if you can have two WANs and two VPN tunnels. So if one VPN tunnel drops, the second one will automatically. It's called VPN trunking. Failover, one failover. So the secondary, this is the secondary WAN. It goes in standby mode and will come online only when the primary one breaks down, right? That's the difference between failover and load balancing, which is, so the problem with this one is when my primary one goes down, I need to detect it. It takes a while, 30 seconds or more. And then I say, the router say, oh, I think the one is not working. I'll just have to fail over, and then fails over. So failover will always have a delay in switchover. So how the load balance works, why, when the traffic goes out, why would it choose 1-1 or 1-2, right? So it does it automatically. And they use these different factors for one load balancing. So you can select which one is going into the load balance pool. You can have 3 or 4 WANs up. You can select all of them, or you can select only 2 of them. I'll show you later. And if you know the WAN bandwidth, you can choose either auto wait. The router will do it by itself, or you can specify the line speed. Let's say, for example, you're sure that the service provider is going to give you 200 megabits per second, and you don't want to compromise. You say, okay, I'll set it as 200 megabits per second, and you will see the difference later. Okay. So detecting the WAN utilization ratio, the router will do that automatically. I'll explain to you how it calculates it. And make the load balance decision, IP-based or session-based. I will explain also what's IP-based and what is session-based soon. Right. So the 2 modes to determine the maximum bandwidth of each one connection. So you can see auto wait. and according to line speed, right? You can just select. Auto wait is automatically you leave the router to do the job, which most of the time we do, right? And then you have two modes: the IP base and session base, right? The two algorithms to determine the maximum bandwidth of each one connection. So you have according to line speed or auto detect. You can select it here, line speed, auto detect, right? And you have also load balance wait. This is for the new type of routers where you can set certain give it a certain specification. You give it a weight. For example, you can say bandwidth according to bandwidth or according to the quality or the reliability. Right? I'll show you how. So this is where you select which one is going to participate in the load balancing pool. Like here, all the one are selected, but sometimes you say, okay, I want only 1, 1, 1, 2, and LTE. So you select it, right? Then this enable is to enable the WANs. This one you say, okay, I want them to participate in the load balancing, right? And the advanced mode is for certain traffic, right? Certain traffic, just like banks or governments, they don't want you to change once. Once you start a session with them, you don't change one IP, or else they will say, oh, this one is a bit shady, and I don't want to deal with you. So this is where you specify what type of traffic you want to, will be excluded from the load balancing. Once a session starts, it will not, if it according to this specification, UDP port and all that, it will not participate in the load balancing. So it will stick to only one, right? And these are for the new routers. You give it a weight. I told you about the download bandwidth. You can say how much you want it to participate in the load balancing, when to change one. For example, low latency, low jitter, packet loss. For example, if you say there's too much packet loss, I want it to change one. Okay. So this is how you use it. So it distributes the usage ratio of each one by setting weights for bandwidth, upload and download, latency, jitter, packet loss. And this feature is used by SD-WAN in ACS, bigger ACS. Have you heard about bigger ACS?
I haven't, no.
Okay, it's a management software. It's it allows you to control from 1 to 100,000 users or routers. We have a user in Netherlands. I think they are a service provider. They have about 100,000 nodes. So they control all of them in one go, on one console.
Yeah.
And you can, one day if you want to play with them, if you have like say 10, if you have 10 router, it's worthwhile to look into that, right? So that you don't have to go to monitor one by one. On one console panel, you can see what's happening and do a lot of work.
Who's ACS developed by?
It's developed by ACS, but DRATEC.
Oh, okay. So it's
it works.
Okay.
It works only on DRATEC routers.
Right.
Okay. So these, when you use older routers, the way that you select the load balance, you have to select one by one, and then you click on load balancing. That's for older routers. And according to line speed, instead of using auto detect, you calculate the line speed and then you enter it here. So technically, you do a speed test like there, 10.56, and the second one is 12.10. You make an average, 11.33, and the upload is
0.85 plus 0.82, make an average, and then you enter it here, 11.3 and 8.35, right? So
Yep.
this is, if you want to use, you specify your own speed, right? But most of the time, as I say, you use auto, it's easier. But some people, for some certain cases, specific cases, it's worthwhile to look into that, but not at this stage. So this table shows how it works. Auto wait, the router keeps tracking automatically. If you do according to line speed, you enter the maximum bandwidth you're supposed to get from the ISP. The pros automatically detect, so you don't have to play with that. And according to line speed, as I said before, that's a real bandwidth ISP promise. You know, they promise a lot of things here, but anyway. And for auto wait, the real bandwidth may vary from time to time, so it's easy to use auto wait. But if the one bandwidth is very stable and rarely drops, this is where you use it. So detecting one utilization. So how does the DRATEC router do? It looks at according to the percentage usage. Like in this case, you have a 20 megabit per second bandwidth. 10 is in use and 10 is left. So the percentage is 50%. And 100 megabits per second line, 90 megabits per second is used, so it's 10 left. So how do you calculate it? We take another case, right? 10 megabits, 20 megabits. You use 5 megabits of each, and then you calculate the one ratio, and you will see that the 1:2 is much better, right? The ratio is much better for 1:2. So any other traffic will always calculate and say, okay, which one is less used? Okay, let's go to a small quiz, very quick. Ideally, in what scenario, according to line speed, load balance mode is recommended? Is it when using a VDSL2 connection? Is it more than 50 megabit per second download speed? When there is a stable internet speed connection, or when there's an FTTP internet connection? What do you think that would be? Sorry.
I'd say it's C, stable
C.
internet connection.
Okay, yeah, that's good. So that's very good. Following. So the one, load balance modes. You talk about the IP-based modes and the session-based mode, that your question was. Okay. So this is how we select the base mode, IP-based or select session-based. In IP-based mode, load balancing, the destination is the same. So if you start a job with an external IP address, so like for example, a server, the connection will stick to the 1.1. It will not change. Just like if you work with a bank, don't change your WAN connection.
Is the IP based on the LAN client or the server?
The WAN.
Which side?
The WAN address. When you address to someone on the internet, they will see your WAN IP, right?
Yeah.
Okay, and then you say, this one, I know which one IP is talking to me. And then we change it.
Okay.
If you use session-based, you change it. The financial institution will say, I don't like that. What's happening? Right? They will break, it will cut the session. So this is where you have to use IP-based. And like in this case, everything will go to, once it starts, it will go to this one. And when you do a test result, the test will see, okay, 1.1, I'll give you the 1.1 speed. It won't give you the 1.2 speed, right? But if you start another session, speed test, it takes 1.2, and then it will give you the test result, it will give you 1.2. And then you say, why my test results change all the time, right? So this is IP-based, it will give you one the test for one at a time, right? So IP-based mode, the test result will be for a single one, depending which one is selected. So for one aggregation, we use session-based, right? That's where a video showed. You just select session-based, and of course, the load balancing, those participating in the session base must be selected as load balance, right? And session base, the session will be split into either 1-1 or 1-2. Right? The packets will be split, and when you do a speed test, even the same destination is the same server, the traffic will be split into multiple one connections. That's why you can have an aggregation of both one speed. The session base in the OSI model is on layer 5, right? It's not the physical bonding that other service provider, Cisco.
Layer 1.
Yeah, they do on layer 1. It's session base, it's on this layer, and it allows you to use different ISP.
Okay.
Yeah. So the case number 1, you have 2 WANs, and the total will be about approximately an aggregation of 50 and plus 100 is 150. And if you have 3 WANs, you get an approximate summation of all these 3. Right? No, the result may be different if you use the same ISP on the 3 of at least on the 2 of them, because I don't know if you know about contention ratio in an area. You got 50 person using the same session. So you have to be careful if you use the same ISP. But if you use different ISP, that definitely will work. So this table will show the difference between using IP-based and session-based. So balance per session source and destination IP. So it sticks to the same one. If you use session-based, they will use the two. All the ones will be used, right? And IP-based, only one single one for one session will be single one. For session-based, all the one combined, all the ones which have been selected. IP-based is accepted by all secure connection, bank, financial institution, government. With session-based, you will get higher throughput. And of course, the cons is this one has the lowest throughput, where this one, the banks and all that, they will not accept that. So we have an exercise how to do the test one aggregation, just like the video.
Mm-hmm.
If you look at the page 20 and 21, maybe you'd like to try it now. You just if you have your LTE, do you have your LTE on? No.
Yeah.
Okay. So without just single LTE, you can do the speed test and see what speed you get. And then you disconnect LTE, you set the Ethernet or the second one, you get to see what speed you have. And then you put both together and set session base. Very simple. So maybe we can see, Edward, do you have, can you see? So we'll talk about the failover. When we do failover, you have to select it here, failover instead of load balance. You say failover, and you can select which one you want. If it's disconnected, like 1-1 or 1-2 is disconnected, then the failover will take over, right? So
yeah.
Here you can also select all of the ones are disconnected. I'll explain to you how that works, right? And you can also have with the new routers a predefined threshold, such as traffic threshold, latency, jitter. So if it hits this threshold, I want to have a change of a failover choice, right? Of course, single WAN routers will only have one failover option. And the cons is you have several ones, you're using only one, and there's a delay in the detection and transfer. I'll explain to you how the delay works. So the failover options is any of the selected one. This is easy. If one is disconnected, then the failover takes place. But all of the selected one disconnected, I should explain to you that how it works. This one is any of the selected ones disconnect. You have 1, 1, 1, 2, 1, 3. 1, 3 is off, 1, 2 is off. Nothing happens. When 1, 1 goes off, even 1, 2 is on, 1, 3 will take over, right? This is when you set it is if 1, 1 goes down, then the 1, 3 will come up, right? And all of the selected ones, in this case, is 1, 3 stays off, 1, 2 goes offline.
Yep, that makes sense.
And then when 1, 1 goes off, then 1, 3 goes up, right? So that's the only difference. Additional options available with later models, and this is where you put upload traffic, download traffic. You set up a limit, a threshold, like the traffic here is 1,500 megabits per second. And latency, you can see what's the latency you're looking for, or jitter, if the jitter exceeds certain level, or packet loss. Then the failover takes place. Now, you have to detect for failover. You have to detect when there is a WAN detection, right? You have to detect when there is a WAN failure. So the DreTech router has 4 of them: op detect, ping detect. One is always on, and we use it most of the time for diagnostic purposes, and strict ARP detect, which is a bit similar to ARP detect, but slightly different. So ARP detect mode, 1, sends an ARP, and every 30 seconds, it sends an ARP sent, and expect an ARP reply. If it gets an ARP reply, you say, okay, the one is okay. But if after 30 seconds, it doesn't get ARP reply, every 5 seconds, it just try again. And then after so many retries, it says, okay, this 1, 1 is not working. Let's go back to 1, 2. Right. And yeah, that's when this fails, 1, 2 takes over. So remember,
is there any performance hit if it needs to swap, if it reaches that threshold? Is there any performance hit? For example, if you misconfigure the detections to detect too early, does it have any effect on is there any failover time?
Of course, if you say, I want so many jitter, and you put the level too low, it will change one all the time. It will swap all the time. So you really need to know what type of threshold you want, right? Or you just set all of them as default, and then it will work as default. Yeah, and sometimes you don't want too many failover. Remember, each time there's a failover, you have 30 seconds or more to wait, right? So it will be a bit annoying. Okay, so this one, when 1 goes down, failover is easy. So now this is where you select it here, right? Strict op detect mode is the same thing. Instead of 30 seconds, it's every 5 seconds. It's supposed to be faster, right? But still, you have 5 seconds detect. I don't I don't get any reply. I try again, second times, and several times, and then I say, okay. But my 1.1 is already gone, so I'm still waiting. And you can also tweak the time interval by using OneDetect command line, right? So we have the same problem. So another limitation of OpDetect is you have a modem here, right? The one asks send an OpDetect, the modem replies, okay, I'm good. But what happens is internet on this side is broken. You resend another op, the modem replies, or anything in between you and the NVN. Like if you have a switch, for example, the switch will reply, hey, I'm here. So, and you still don't have internet. So that's a bit annoying, right? That's one of the limitations of OpDetect. And that's why people use the ping detect mode. So you send a ping, the ping goes on the internet, right? Google replies, okay, I'm here. It's much better, right? So if you don't get a ping, then you know the one is down and the second one takes over. So you tell me why people use OpDetect, but it's by default, it's like that. So most of the
use
time,
ARP, for example, on like an Aussie broadband connection where you don't need that modem. But as soon as you need a modem into step, you should use ping detect.
Yeah, that's right.
Okay.
So because by default, all the routers come with OpDetect, and then you say, oh. Sometimes Starlink, when you use Starlink, also we recommend people to use ping detect because Starlink is another thing in between, right? And again, there's the ping detect. You can detect this. You can decide the ping interval and how many retries you want. By default, it's like that, so it's up to you. You can ping Google. Okay, you can ping your own server. If you have a server you use all the time, you can ping it. Or basically, we tell people to use Google.
Use Google, yeah.
Yeah.
Because they're never going to go down.
But sometimes if you ping your own server and your server is down, then something's happened, right? So it serves a second purpose also. Yeah. And we have some Linux-based router like 2960 and 3900. I doubt you will have them. You don't have them, right? 2960. And
no, I believe we only have like the one type of DRATEC.
Yeah, and they have another detection which is HTTP, which is similar to ping. Yep. So if you have them, you just use it. I won't spend too much time on that. And this is how you select it. If you have a 3900 and if you have a 2960, this is how you select it. Of course, you put your detection here or 8888 or whatever server you have. So a quick quiz. Number 2, according to this network diagram, which one connection detection should be used to activate the failover connection automatically if primary line is faulty? OpDetect.
Detect.
And answer is ping detect. So very straightforward. So another feature is called OneBudget. It's very useful if you have LTE. Sometimes, because before we had a quota, right? You say you got 50 gig. When my LTE exceeds 50 gig, I want to shut down the interface and send an email or SMS message, right? So this, and then you can reset it monthly or custom. You can decide when you want the quota to be reset. Right? So you can shut down the interface, send SMS, reset quota. And you can also monitor at any date how much of the quota you've been using. You use monitor page, right? So 2 more important things to consider when budgeting is ensure that time and date of the router, of course, we are putting a quota for a date and time. You need this to be configured. And in all the model routers, when you enable hardware acceleration, the one budget will incorrectly monitor one traffic. So just be careful about that. Okay, summary today, we talk about load balancing and one failover. We could talk about session-based aggregation, and we talk about the one detection, and we talk also about budgeting. We did a hands-on exercise on one aggregation, and the second one, we will do one failover using ARP and ping detect. Right, so this is the second test on the page 36 to 38. I'm not sure how you will set it up, but we need to have a switch in between. Do you have a switch? And if you have an internet connection, you go through the switch. So when you, basically what will happen when you send a ARP detect, the switch will reply. So even if you disconnect the internet here, the switch will continue to reply ARP detect. This is where you have to change it to ping. When you send a ping, the ping goes through this, goes through this, goes through this, and then since this is broken, you won't get a ping back. So if you can try that.